So we are going to start our class. Okay. Divyanshu, you have turned off mute yourself and video also mute. My screen is going back after some time. Okay. So students, as you see on your screen, that long form of Mendeleev periodic table. Okay. So you can also see on your book. I am going to just discuss whatever we have learned till now. Okay. So in modern periodic table, we know that there are two forms there. Okay, periods and groups. So in periods, we first period is shortest period. Okay, as you seen here, first period is from left to right. Okay, so you can see only two elements are here. So it means it is the shortest group. That's why it is called shortest group. Okay, if we talk about again other second period, okay, they also contain 8 elements in there. Okay, so whenever I just want to describe you, I know that you already read it. Okay, that whenever you read something in your book, just match with the periodic table so you can easily understand the periodic table. Okay, today we will discuss about the alkali metals. Okay, you know that we already discussed about groups and variation in the properties of elements in the periodic table. Okay, so today we will discuss about the special reference to alkali metals, that is group 1 alkaline earth metals and halogens and zero group. So first we are going to discuss about the alkali metals. So group first of long form of periodic table or group first A according to Mendeleev periodic table and group 2 of long form of periodic table. Okay, whenever we are talking about group first, you can match it, okay, with your periodic table also. Okay, and group second A, if we see the Mendeleev periodic table, it will be group second A constitutes the S block elements. Okay, it is also known as the elements which are found in this group, also known as S block elements. Why they are known as S block elements? Because in their last cell, if you see the filling of electron, their electronic configuration, if you see, last electron will be filled in S subcell. Okay, so all the members of first group possess one electron in their outermost S cell and show the tendency to lose one electron. All these are metals. So all the groups of first group are metals, and I already told you in periodic table, in left hand side, if we see the left hand side of periodic table, there are only metals are found, and in right hand side generally non-metals are found. Okay, so if you see in group first A, okay, if we see the electronic configuration of lithium, it is according to helium. Okay, 1s2 helium's electronic configuration 1s2, then 2s1. Okay, then from for sodium, it is equal to the neon. Okay, I already told you that how configuration is written. Okay, all students are listening na? Oh, okay, 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 one person speak only, okay? It's, okay, when I ask you, then you will be talk. So, next slide. Okay, then other if we know about the alkali metals, is that group first contains the alkali metals, which include the typical or representative elements such as lithium and sodium, as well as potassium, rubidium, cesium, and francium. Okay, whenever you read about elements, you just put a tendency to read their full name. Okay, that's why you are not confusing in future also. So these are known as alkali metals. Okay, first written alkali metals. Why they are known as alkali metals? Because they form water soluble oxides and hydroxides with combined with water to produce strong alkalis. Alkalis means bases. Okay, so now we read about the characteristics. What are the characteristics of these alkali metals? Each member of group first A or group first has an s1 arrangement of element electrons, where n represents for the outermost cell. That is, all these members possess only one electrons in their outermost cell. Okay, as you see in page number 178. Okay, followed with n minus 1 s2 p6 or n2 1 ns2, that is in lithium. Okay, if we see their electronic configuration, as I already told you before, that they contain their last electron in s subcell. Next is, because of similarity in electronic configuration, they exhibit similar properties. Okay, a regular gradation in their properties with increase in atomic number is observed due to increased size of atoms or ions and the low binding energy of valence electrons. Okay, so what it want to say, that a regular gradation in their properties. Okay, after increasing their atomic number, suppose lithium has 3, then sodium has 11, okay, potassium has 19, and so on. So their properties also increase. Okay, and because their atomic size is also increasing. Okay, and their binding energy with valence electron which bind each other, it also begin to low. In third characteristic, of all the alkali metals, only sodium and potassium are found in abundance in nature. Okay, as you already know that uh, francium occurs only in minute quantities as a radioactive decay product. So only one radioactive element, if someone asks to you in the first group, is francium. All are light metals. Lithium, sodium, and potassium have density less than water. Low values of density are because these metals have high atomic volume due to larger atomic size. On moving down the group, the atomic size as well as atomic mass both increases. Okay, so this is the headlines. Whenever you read some peculiar characteristic about the characters of group. Okay, so kept in try to remember it, or kept in mind that whenever we move down in the group, atomic size as well as atomic mass both increases, but increases in atomic mass predominates over increase in atomic size or atomic volume, and therefore the mass or mass upon volume ratio, that is density, gradually decreases down the group. Okay, however, K is lighter than Na. Okay, there are some exception whenever you read about the chemistry. Many exceptions are there. Okay, so they said that whenever we go down in a group, density gradually increases, but one exception is there. Potassium is lighter than sodium. Now we move to the alkaline earth metals. Okay, so why they are called alkaline earth metals? Because the same thing they do whatever things do by alkali metals, okay, they also form sodium soluble oxide and hydroxide when combining with water. So all the elements of second group possess two electrons in their outermost shell and possess the tendency to lose two electrons, showing the valency 2. All these are metals. Okay, so group 2 also uh, contain metals. Okay, in group 2 also metals are found. So if you see, their electronic configuration will be ended in S subshell and it will be in last come within 2s2 in all these elements. Okay. Group 2 contains the alkaline earth metals, which include the typical elements beryllium and magnesium, as well as uh, calcium, uh, strontium, barium, and cerium, barium, and radium. Okay. So these are known as alkaline earth metals. Why these are known as alkaline earth metals? Because their alkaline oxides are non-fusible like matter, silicon oxide, and were known before the discovery of these elements and thus are called alkaline earth metals. Or generally they are in, if we see the previous definitions when chemistry is not so developed, these metals, if you see, generally found in earth crust. That's why they are known as alkaline earth metals. Okay. So now we read about the characteristics of alkaline earth metals. First characteristic is that don't use pen like that. So each member, okay, you can see on your book also, each member of this group, second has ns2 arrangement of electrons where n represents outermost cell. Okay, I already discussed about it. All these members possess two electrons in their outermost cell, which is s. Because of similarity in electronic configuration, they exhibited similar. What they exhibit? They similar properties. A regular gradation in their properties with increase in atomic number, as we seen in group first also. So radium being most radioactive element. One most radioactive element found in this group is radium, and its half life is 1600 years. Okay, its half-life is 1600 years. As we move on reading about further characteristics in metallurgy in high classes or in other chapters, okay, you will be read about the half-year of any radioactive element. Now, if we read about the halogens, okay, group 17. So group 17 of long form of periodic table. Okay, when you go to higher classes, you have to read about all the groups, but in your ninth class, okay, the major groups are given which you have to read. So next is halogens. Group 17s are also known as halogens. So previously reported as 7th A according to Mendeleev periodic table includes the non-metallic elements. So now, as we already tell to you that in left hand side generally metals are found and in hand side of periodic table non-metals are found. So these are non-metals: fluorine, chlorine, bromine, iodine, and astatine and tennessine. Okay, so these elements are collectively known as halogens. Don't do this type of misbehave in class. Otherwise, I told to principal sir. Otherwise, I have to mute yourself. Okay. So these elements are collectively known as halogens as their salts are usually found in seawater. Why they are called why they are called halogens? Because their salts, okay, salts are generally found in sea water. And how salt is formed? I hope you all know that when acids and bases are react with each other. All the members of 17th group possess 7 electrons in their outermost shell. So if you see, that's why it put in 7th group. So outermost electron is first. If we read about the fluorine, okay, it has the similar configuration of helium 1s2, 2s2, 2p5. And if we uh, write electronic configuration of chlorine, it is equal to the first neon, okay, then 3s2 and itself fill in the p block, okay, 3p5 similarly. So you can see last two elements of last two electrons are their outermost shell is found in s and p group, s2 p5 same. So characteristics of these halogens are all these have general configuration ns2 and p5. The different suiting electrons enters into the p subcell and thus named as p block elements. Okay, so whenever any electrons which enters in the any subcell, its block also named as there. So the outermost cell configuration, okay, so outermost cell configuration is like that. As you already know that in s block only two electrons can come, so it written as 1s2. And in p block elements maximum 6 electrons can be enter. Okay, so and filling of electrons, when you go in higher classes you read about the Hund's law. Okay, so first electron is filled in each cell like that, then the second electron will be filled in that way. So if these electrons are filled in D group or D block, which has maximum tendency to come up with 10 electrons, okay, so then any group titled is D block elements. All the elements of halogen family are non-metals. The non-metallic character decreases down the group where metallic character increases. Iodine develops some metallic characters shows the following characteristics of metal. Iodine is solid in form. It has metallic luster also. Okay, it has a violet luster if you see that. Fluorine is light yellow gas. Chlorine is greenish yellow gas. Bromine is brown liquid and iodine is deep violet. Halogens are most electronegative elements. Fluorine has maximum electronegativity among elements and all possess the tendency to gain one electron forming anion. So most electronegative element of group 17 is fluorine, and it has a great tendency to accept the electron. Now I hope you will be understand till here. Any confusion till here? Okay. Now we move to the zero group or group 18. So as you know, in zero group, all the noble gases are put there. So noble gases were not known at the time of Mendeleev, and thus he did not felt left any place for them in this periodic in his periodic table. Ramsay in 1896 suggested a new group after the discovery of helium and argon in the periodic table. Later on, other elements of this group were discovered and placed in zero group, six elements. The zero group occupies the intermediate position between the strong electronegative elements of 7th A and strong electropositive elements of first A groups in the periodic table and thus act as the breeze. If you see the position of in periodic table group 18, it is intermediate between. Okay, the strong electronegative elements, which is of 7th A group, okay, and electropositive elements of first A group. However, in long form of periodic table, noble gases occupy group 18 and are placed in on extreme right side of the table. If you see in new modern periodic table, this is the last. Okay, as you see already. Group 18 of long form of periodic table previously reported as group 0 according to Mendeleev's periodic table includes the non-metallic elements helium, neon, argon, krypton, xenon, radon, and oxygen. Sam. All the members of 18 group possess 8 electrons in their outermost shell, okay, except helium. So you can see 1s2 its configuration, and for neon 2s2 2p6, and for argon 1s2 2s2 2p6 3s2 3p6. It dot dot means you have to fill it, okay, before that, or you can write just neon in place of it, or argon whenever they comes to the down to the group. For krypton, okay, we can write argon 3d10 4s2 4p6. So you can see that outermost electrons, there 8 electrons, so they uh, filled, they are stable because they have 8 electrons in their outermost cell. We will read further now when we read about their characteristics. So all these gases except helium possess ns2 np6 configuration. The differentiating electron except helium enters into p subcell and thus are included in p block elements. All of them have their outermost shell with complete octet except he, uh, helium, which has 1s2 configuration, a completely filled first cell. So it is also stable because it has also complete filled cell. Their outer cell electron is, if you see in their electronic configuration, okay, helium has 1s to 2 electrons are there, and rest all they have ns2 number, okay, and np6, okay, number n means the number of electrons. So because of completely filled outermost cell or stable configuration, these elements have no tendency to lose or gain electrons and thus usually do not participate in chemical reaction under normal conditions. Okay, so basically any elements have a tendency to gain or lose electron to form this octet state. Okay, every element wants to be in this state. That's they are very eager or always try to lose an electron or gain electron to complete their electronic subcell, but these are already filled. That's why there are no chemical reaction shown by them. So all of these are gases under ordinary conditions of temperature and pressure. All of them except radon, oz, which are radioactive, are present in atmosphere in minute quantities. Radon is obtained from radioactive distillation of radium. Okay, so on account of their very minute quantities in atmosphere, they were named as rare gases. Why they are known as rare gases? Because they are found in very small quantity, or you can say some 0 point percentage, so very minute quantities, they are found in atmosphere. Okay, whenever you read about the atmospheric gases, so their quantity is very less. That's why they are known as rare gases. Due to their chemical inactivity, these were named as inert gases also. Inert means acrid, okay, which are not react with any type of chemical reaction or any element. However, a number of xenon compounds and two krypton fluorides were prepared, and thus they were named as noble gases. Okay, now very xenon compounds and krypton fluorides were prepared, and thus they were named as noble gases. All of them are monoatomic gases. Okay, so these all, if you see their electronic configuration or their writing formula, they are monoatomic. They contain only one type of atom. So what you will be read till here, that a periodic table is an arrangement. Okay, because these are the points, important points to remember, you have to see whenever you read any chapter, because these are the summary whatever you have read on this. So a periodic table is an arrangement of all non-elements based on a certain law known as periodic law, in a manner that the elements with the similar properties fall in the same vertical column. Okay, another thing to make periodic table is to that we just, if I talk about the sodium, okay, sodium is told in India by sodium, and in local language it can be tell any other name. Okay, so providing names also is a peculiar characteristics of this periodic table. So if we talk about sodium with an American, he also understand. So a second point is to remember that Tavernier arranged the elements in a group of three called triad in such a way that the atomic mass of the middle element is almost equal to the average of atomic mass of the other two elements. Okay, we already read about this law in detail in the last classes. According to Newland's law of octaves, if the elements are arranged in the increasing order of their atomic mass, the properties of every eighth element are similar to those of the first one. Okay, this is also a good law, but it is only fixed to the some kind of elements. Then a new form of periodic table comes, which is most acceptable at that time according periodic law. The physical and chemical properties of elements are the periodic functions of their atomic mass. So its table is based on periodic law, which is elements in this periodic table are arranged in 7 rows called periods and 8 vertical columns called groups. Mendeleev's periodic table helped in the systematic study of elements, discovery of new elements, and correction of atomic masses. However, it has several defects, as we already did in later classes. So, the long form of periodic table is based on modern periodic law, which states that the physical and chemical properties of elements are the periodic functions of their atomic numbers. The long form of the periodic table consists of 7 periods. First period is the shortest period and consists of only 2 elements. Second and third periods are short periods, each containing 8 elements. The fourth and fifth periods are long periods and contain 18 elements each. Sixth and seventh period are the longest periods and contain 32 elements each. Okay, so if we talk about the periodic table, it is normally based on the periodic table. Whenever you anything want to learn or solve any question, just you have to memorize this periodic table. Okay, In later class, I will be discuss or make a video on how to memorize this periodic table. Okay, so you can easily do any question of this periodic table. The long form of periodic table consists of 18 vertical columns, which comprise 9 groups, first to 8 and 0 in Mendeleev's scheme, or 18 groups in the new IUPAC scheme. Okay, the number of electron cells remain the same in a period and is equal to the number of period. The properties of elements across a period vary gradually in a regular function. The elements present in a group possess similar type of electronic configuration. Their properties are also similar. That's why we put in the same group. The periodic repetition of elements having similar properties after regular intervals is called periodicity. On moving from left to right, this is main thing in which many questions are asked in exam, that when you move to down a group or left to right in a period, the number of valence electrons increases by 1, metallic character decreases, electropositive nature decreases, valency increases up to fourth group and then decreases, and acidic nature of oxide of the elements increases. On moving down a group, number of valence electrons remain the same. Metallic characters increases, valency remains unchanged, electropositive nature increases, and the acidic nature of oxide decreases. So, if you see in a period and on a group, there is a contradictory. You can easily understand or memorize about it by just they are opposite with each other, their characteristics. The periodic table is helpful in the systematic study of elements, in the discovery of new elements, and in the correction of atomic masses. So this is the main, you can see, importance of this periodic table is the it provide a wealth of information regarding elements and their compounds and their chemical properties. So if you have any confusion till here, you can ask. Anyone have all you understood? You can raise your hands if you understand all things. Yes. If you have any question, and now discuss about some question. If you whenever you have to solve any question, when I say to solve, okay, just solve according, because the answers are given on your book also. So you have to do at least 30 to 50 short 30 short answer at least on your notebooks. Okay, and very short answer you can easily memorize, so do little bit 20 30, like that you have to do, because many questions are there. Okay, so it's not possible to solve each and question for you. And uh, whenever mainly you go further, questions which are coming from 2015 to 18. Okay, previous year's questions you can solve them. Any suggestion for your class, or any confusion or anything, whatever you want to give your feedback, you can give. Okay, all students will be understand na, this chapter. Okay. Okay. So in next class we will read about hydrogen. You are ready to understand, because understand this period table very carefully. Okay, because it is very important chapter for your because whatever chapter is comes next. about electronic configuration or anything. If you have any confusion, any person, any student, okay, so you can ask to me, so I can make a separate video on that topic. So now solve the questions and answer of this chapter. Okay. Any other class also today you have? Okay. So in the next class we will read about hydrogen. Okay. Okay. Thank you.